Welcome to Shifting Grades. The subtopic is the distance along a small circle. We have looked at the distance along a great circle, both in kilometers and in nautical miles. Before we look at the distance between places on the same small circle or a parallel latitude, I can give the relationship between nautical miles and kilometers. And we say that nautical miles is the unit used to measure distance in the sea and in the space, or the distance used by the sailors. We say it is nautical miles. Therefore, nautical miles is related with a kilometer such that 1 nautical mile is equal to 1.853 kilometers, like that. Therefore, we have this relationship between the two units of measuring distance. We know what small circles are now. Let me try to sketch. We said small circles divide the sphere into unequal portions except the equator. The equator behaves like great circles. So for a great circle, we had said that if this is a great circle and we have a place here and another one here, then the center of the earth is somewhere there. The center of the earth. We say this place can be connected through the radius of the earth and this one. Both places can be connected to the center or to the interior, exact center of the earth. And now, because we are assuming the earth to be a perfect sphere, then this can be treated as a normal arc. And we use the angle in between the two places. Now, for the case of small circles, we know that small circles, they continue becoming smaller the more they move from the equator, either upwards or downwards. Therefore, you find, now, if you consider a small circle like this one now, for a place which is along these two small circles, between A and B, these are two places along a small circle. But now, this circle, which is assumed to be going through the globe, cannot be having an equal radius as the sphere. And that's why we say now, in this case, you find the radius now is changing. We find the smaller the circle, the smaller the radius. It is only along the equator where we can say now from here to the center of the earth is having the same radius as the earth. But for a small latitude, then you find that the radius of this latitude is not the same as the radius of the whole globe. Therefore, you find that now we are having a smaller radius. Let me demonstrate what I'm trying to say. This is what we're saying, that when you consider a great circle like this one, you can relate from here to the center and from here to the center again. Then you treat this one as an arc, like that, and you use the angle in between them. But for a small circle like this one, you find that a small circle like this one, the radius from here to the axis of the earth is a radius which is smaller and far much smaller when you compare it with the radius of the earth. And that's why now we are saying this. We can now be taking, if a small circle is somewhere here, and we treat this one as the axis of the earth. Axis of the earth. Then, this is the center of the earth. Therefore, we can say this, that from here to this part, as long as it is on the surface of the Earth's surface, it is r, where r is the radius of the Earth. But now the small circle which is here, the small circle which is here is having a smaller radius. So we have a smaller radius here, but this is the radius of the Earth. So this is the radius of the Earth all through. But for this small circle or this latitude, we are having a smaller radius. Therefore, we can get this radius by saying, because these two radius are very parallel to one another, and there is an angle here, then we can say this angle is equal to this one, because this can act like a transversal, because small r is parallel to the capital R. Therefore now, because this r is known, and this angle is known, this angle, theta, is the latitude itself. So, where this latitude is, where that latitude is the size of this angle. If we say this is latitude 40, then it means from here, 0 degrees, because this is equator. From 0 degrees, which is the center of the Earth, up to where a latitude is, the angle which has been cut through is the size of that latitude itself. Therefore, if we have gone to 40 north, then it means we have gone through an angle of 40 from the equator. And therefore now, we can relate this now through trigonometry in book 3, and we can consider this triangle. If we call it triangle OMN, if we consider triangle OMN, let me draw it here. Like this, with an angle theta and a capital R, a small r, then MON. Then when we extract that triangle now, we can relate and say the cosine of this angle is given by the adjacent side, which is r, divided by the hypotenuse. And the hypotenuse is capital R. Therefore, we can multiply through by capital R, and by multiplying by capital R through, then we can have small letter r cancelling 2. R cosine of the angle. And we have said that this angle is the latitude itself, because for us to arrive at a given latitude, then we have swept through an angle which is equal to the position of the latitude itself. Therefore now, with that, we can say this now, because we have known now what the small radius in latitudes is, or in small circles, then we can say this now. The distance is calculated by, when we take the angle alpha times 60, then the cosine of that angle, the cosine of theta, this is in nautical miles. And for kilometers, we take again the difference in longitudes times, or divide by, because it is the theta, divide by 360 to pi. Then instead of r now, we have calculated and found that small circles have a smaller radius, and the radius is given by the radius of the Earth times the cosine of theta, and theta is the latitude where that latitude is. Therefore, now instead of r, for this case, we will use capital R times the cosine of theta. Therefore, this one represents the small r in small circles. So this is distance in kilometers. So for these formulas, we can say where alpha is the longitude difference, and this one, beta, is the latitude of the small circle, or where the small circle is. Therefore, with that, we can simply state these formulas by saying the distance is gotten by difference in longitudes times 60 cosine of the latitude. Or, for kilometers, alpha all over 360 2 pi r cosine of the latitude. So the formula can be stated simply this way. I would like to give an example on the same. So those are the formulas on how the distance along a small circle is calculated. Let me give an example. We are told to find the distance in kilometers and in nautical miles. Find the distance in kilometers and in nautical miles between two places A, 50 degrees south, 25 degrees east, and B, which is 50 degrees south and 140 degrees in the east. So we are taught to get the distance between these two places. A, 50 south, 25 east. B, 50 south, 140 east. Let me sketch. I will try to sketch the two places, locating the places. This is 0 degrees prime meridian, 0 degrees equator. Then we are told 50 degrees south. So south is the lower side, 50 degrees in the south, and 25 east. East is the right hand side. So 25 east. 25 degrees in the east. Therefore, where 50 south and 25 in the east are intersecting, they give us our point A. B is 50 south, the same latitude, and 140 in the east. So A is very far, 140. So A is 140 degrees in the east. Meaning, now where 140 and 50 are intersecting, they give us our point B. Therefore, we are getting the distance now for these two places, the distance, and we have said that, let me use this part. We have said that the formulas are here. Let me start Roman 1 by getting the distance in kilometers. Distance in kilometers is given by alpha all over 360 2 pi r cosine of the latitude, where the two places are. And we will say that the difference in longitude, B is at 140 and A is 25. They are both on the east part, meaning that the difference in longitude, we will take the difference because they are on the same side. Therefore, 140 and 25, the difference is 140 minus 25. Those are the difference in longitude in between. Therefore, it will be 140 divide minus 25. Then we divide by 360. We multiply by 2. pi 22 over 7, 6370 is the radius of the earth, cos the latitude. They are on latitude 50. They are on latitude 50. Therefore, we can take the difference between 140 and 25, which is 115. So 115 all over 360 2 pi r cosine of latitude 50. Therefore, the distance is 115 times 2 times 22 times 6370 cosine of 50. Then we divide this by 360 by 7. And this is giving us a distance of 8221.61 in kilometers. So this is the distance in kilometers. In nautical miles, distance in nautical miles, we said it is given by alpha, which is the difference in longitudes, times 60 cosine of the latitude. Again, cosine of the latitude. Therefore, the difference in longitudes we have calculated already. It is 115 times 60 cosine of the latitude. The two places are on the same latitude, latitude 50. Therefore, 115 times 60 times cosine of 50. This gives us 4435.23. These are nautical miles. Therefore, this is how we get the distance for two places on the Earth's surface. I will give another general example. We will examine the type of the places given there, and we will be now evaluating whether it is a small circle or it is a great circle, and then we go on to calculate a question whereby we have not been told it is a small circle or a great circle, and by analyzing the question we'll be able to know whether it is a small circle or a great circle. Then we now solve it. Let me read the question. The question says, find the distance in nautical miles between point A. Find the distance in nautical miles between point A, and the coordinates of A is 45 degrees in the north, 45 north, 35 west, and B. Then B is given as 45 north, then 100 east, along a parallel latitude. Therefore, this is along a latitude. Solution: the distance between A and B along a parallel latitude. We can sketch the two places on the Earth's surface just like this: 0 prime meridian and 0 equator. Then 45 north. Therefore, 45 degrees north is here. 45 degrees in the north. The two places are lying there on that same parallel latitude. Then we are told A is now 35 west. Therefore, west is this side. 35 west. So where 35 west and 45 north are intersecting gives us A, but B is 100 in the east. So side here east, 100 degrees. Therefore, this is where we have B. Therefore, now we are seeing that now, after plotting, the two places are along the same latitude. Therefore, now we can get the distance in nautical miles. And in nautical miles, we said the distance is the change or the difference in longitudes times 60. then cosine of the latitude where the two places are. And therefore, we can check. One is 35 west is this side, and 100 east. Therefore, the two places are on opposite sides of the prime meridian, and therefore, longitude difference, we are going to take the sum of 100. Alpha will be the sum between 100 and 35 because they are opposite sides. In case it was the same side, we could have subtracted. But here we are seeing from 35 to prime meridian, then 100, meaning the difference between the two places is the sum. Therefore, 135. Therefore, now the formula, we will have 135 times 60 times the cosine of, they are on latitude 45. Therefore, cos 45. Therefore, when you compute this, 135 by 60, cosine of 45, this gives us 57.56. These are nautical miles. Therefore, that's how we get the distance along a small circle, because the two places are on a parallel latitude. And we said that latitudes are small circles. So the two words can be used interchangeably. You can be asked a small circle or along a parallel latitude. It's upon you to know that it is just the same language. Another question, so that you may look at something else. Find the distance between points P. The distance between points P, and P is 35 degrees north, 50 degrees east, and Q, which is 30 degrees south and 50 degrees east. Find the distance between points P with the given coordinates and point Q with the given coordinates. Solution. We can very fast come up with this sketch of the two places. Therefore, with the globe like this, 0 degrees equator, 0 degrees prime meridian, 35 north, and 50 east. So east is this side, 50 degrees east. Where 35 north and the 50 east have intersected, they give us our P. Then the other one is 30 south, 30, the southern part, and 50 east. So the same, it means the two places are on the same great circle. Therefore, both P and Q are on longitude 50 degrees in the east. This is an indication that now we are calculating distance along a great circle, because not A and B, P and Q are on the same longitude. It means we are getting distance along a great circle or along a longitude. And the distance is given by, when you take beta all over 360, 2 pi times the radius of the earth. And beta is the difference in latitudes. Therefore, the two places, one is on 35 north and the other one 30 on the south part. So the difference between the two is when we add, because this is 35 on this side and the 30 on the other side, then it means the difference is all this difference, 30 north and the 30 in the south. This is 35, that is. Therefore, 35 plus 30, it will be the difference between the two places. Therefore, 35 plus 30 becomes 65. divide by 360 times 2 times 22/7 times 6370. Therefore, the distance in kilometers between these two places is 65 by 2 by 22 times 6370 divided by 360 times 7. This is 7,229.44 kilometers. We can get the distance in nautical miles. In nautical miles, we know that the distance is theta times 60. And the theta is the change in latitudes, which is already calculated as 65 times 60. 65 by 60. This gives us 3900 nautical miles. Therefore, the distance in nautical miles is 3,900. The distance in kilometers is 7,229. With that, I would like to give something, and that is the shortest distance between two places on the Earth's surface. The shortest distance, between two places on the Earth's surface. To determine this, we are going to follow an example. Then we are going to say, consider, let me give the example. Consider two places. P, which is 50 degrees north and 48 degrees west, and another place Q, 50 degrees north and 132 degrees east, like that. Then you are told find the distance from P to Q. The distance from P to Q in kilometers. Then part 1, we are taught along a parallel latitude, and part B, or part 2, sorry, along a great circle. So that's the question. We are going to consider this case, and from it we shall conclude something here. We will be able to conclude something. Solution. We're going to do this question together. We are told places P is 50 north, therefore we sketch 50 north and 48 west. So west is on this side. This is 48 west. Like that. Where they intersect, we have our P. Then Q is again 50 north and 132 east. Therefore 132 east. 132 east. Therefore, this is where we have our Q. Therefore, we want to get the distance between P and Q in kilometers along the parallel latitude. Therefore, from P to Q along this latitude, we know that distance from an 1, distance along a parallel latitude and in kilometers is given by theta all over 360, 2 pi r cosine of the latitude. Therefore, theta, because they are on opposite sides, this is 48 west and this is 132 east, then the difference from P to Q will be this 48 plus this 132. Therefore, the distance, the difference in longitudes, because they are opposite sides, then we add 132 plus 48. This gives us 180. Divide by 360 times 2 times 22 over 7 times 6370 times the cosine of this latitude. The two places are on latitude 50. Therefore, we multiply 180 times 2 times 22 times 6370 times the cosine of 50. Then we divide this by 360 by 7. This gives us 128.61 kilometers. So this is the distance in kilometers along the parallel latitude. We can check now the distance along a great circle. Now, when two places are not on the same longitude, but you're being told to get the distance along a great circle, and we are sure that they are not on the same longitude, what you do for this case is you get the distance from P to the North Pole, then down again to Q. That is the distance we get. Therefore now, if they are on longitude, we are solving number 2. If they are on longitude, latitude 50, then it means from P to the North Pole, it remains only 40 degrees, because we know that from the equator up to the north hemisphere, you can only turn through 90 degrees. This is a quarter a circle. So always we should consider this, that from 0 degrees equator up to the north hemisphere, we can only turn through 90 degrees. And therefore, if already P is at 50 degrees, then it means the remaining arc is 40 degrees. Therefore, we have from P to the north is 40 degrees, and from north again down to Q, which is here now, we have reached 90 now. So from 90 to 50 again, we have again another 40. Therefore, we can say now the distance or the angle difference, the angle difference along the great circle between P and Q is, we have 40 up to the north, then again from north to Q we have 40, 80 degrees. Therefore now we calculate the distance now, because we have known the difference in the angle. Now we can calculate the distance, and we know that distance is gotten by the difference in the angle all over 360 times 2 times pi times radius, because this is now a great circle, 6370. Then we compute this very fast. 80 by 2 by 22 times 6370. We divide this by 360 by 7. This gives us 8897.78 kilometers. Therefore now, we can see that when we follow a great circle from P up to the north hemisphere, then down to Q, we are getting a distance which is smaller than when we move from P to Q across a latitude. And therefore we can say that now, if we want to get a shorter distance between two places, it is good if we follow from P to the North Pole, then down again to Q, than following the parallel latitude. Therefore, this lands us into a very important note, and we should record it as not. We should say that the shortest distance between two places on the Earth's surface is the distance along a great circle. So, distance along a great circle is shorter compared to the distance along a parallel latitude. So, if you have two places on the Earth's surface, if they are on the southern hemisphere, again you consider the South Pole. If two places are here, P and Q, you won't consider the distance from P to the North Pole, then down to Q. Now, because they are in the southern hemisphere, you consider the South Pole. From P to the South Pole, then again up to Q. That is shorter than when you compare from P along the parallel latitude to Q. It will be a long distance. Therefore, sometimes you'll be given a question and you're required to get the shortest distance between two places. Make sure you follow the distance along a great circle. It is the shortest distance. Let me give an example on the same. An example on the same. You are told, find the shortest distance. Find the shortest distance between A and B. Find the shortest distance between A and B. Find the shortest distance between A and B, and you are given the two places as A is 55 north, then 35 east. B is given as 55 north and 70 east. Find the shortest distance. Find the shortest distance. Sorry, this is west. Find the shortest distance. Solution. You can first of all sketch the two places on the Earth's surface like this. 55 north, that is the latitude, 55 north. Then we are told A is 35 west. So on the west side 35, we will have A. And on the east side 70, we will have plus B. Therefore, we want the shortest distance from A to B. It is good to note that the shortest distance will be the distance from A to the North Pole and down again through a great circle to B, than following from A to B along the small circle or along the parallel latitude. We can solve it and say from A, which is at 55, to the North Pole, which we said it is 90 degrees. Then the difference here from 55 to 90 is 35 degrees. Therefore, because we are going again down to B, then the total difference will be 35 times 2. Because it is from A to the North Pole and again down to B, which is again at 55 north, therefore 70 degrees. Therefore, the shortest distance between A and B in kilometers will be, the distance is beta, which is 70, divided by 360, multiplied by 2 pi times the radius of the earth, which is 6370 kilometers. When we compute this very fast, we'll be having 70 by 2 by 22 times 6370 divided by 360 by 7. This gives us 7,785.56 kilometers. So this is the shortest distance ever or possible between A and B. We can confirm. In case we follow the parallel latitude between A and B, A is at 35, B is at 70. Therefore, the difference in longitude will be 35 plus 70, 105 degrees. Therefore, now, when we consider distance in a small circle, we will say the distance is given by 105 all over 360 2 pi r cosine of the latitude. They are on latitude 55, like that. Therefore, it will be 105 times 2 times 22 times 6370 times the cosine of 55, and we divide by 360 by 7. This is giving me 86,98.42. And now these are kilometers. Therefore, you can see along the small circle, the distance is longer than when we use along the parallel or along the great circles. Therefore, it is good to note that distance along a great circle is the shortest distance between two places on the Earth's surface. So that's all about the distances along great circle, along small circle, and the shortest distance. In the next time, we will be comparing longitudes and time, and also speed when it comes to the Earth's surface. Thank you very much for watching us. Subscribe to our channel and share our link. Thank you.